Good afternoon, class. We continue with exam 3 review, which covers from 3.9 to 3.11, 4.1 to 4.5. Here's part 2 covering 3.10 and 3.11. 3.10, linear approximation and differentials. 3.11, hyperbolic functions. So 3.10 is linear approximation and differentials. So here's the definition. For y equals f of x, we define dx called the differential of x by dx equals delta x. So if you look at this graph, we have a curve y equals f of x. As we move from P to Q, it creates the change in x run, which we call a delta x or dx, or this distance bp, which is the same as dc. dy called the differential of y by dy equals f prime of x dx. So recall f prime of x is dy dx. If we do the cross product, dy is f prime of x dx. And so what I want you to notice is this. When we have this curve, everybody, delta y is the change in y along the curve. So delta y is this distance of BQ. So in other words, CQ minus PD, CQ minus PD or DP. And so delta Y, this distance, or this distance, is f of x plus delta x, which is this distance, minus f of x, precisely. So the change in y along the curve, that's delta y. What is dy? dy is the change in y along the tangent line at point P. So we have the same, see, delta x and dx, this run is the same for both of them. But this distance, AB, is dy, which is not equal to delta y, which is BQ. However, we can replace delta y by dy for a function f, which is a continuous and differentiable function with a small delta x, if delta y is difficult to evaluate. Therefore, when f prime of x is precisely dy dx, we say it's approximately delta y over delta x, and delta y would be f prime of x times delta x, which gives rise to the following. Delta y is precisely f of x plus delta x minus f of x. So if I move things around, please understand this equation and this equation, just move things around. We know f prime is dy dx, which makes dy is f prime of x dx. Now this delta y, we can replace it with dy as an approximation. Now this point has coordinates a and f of a, and I remind you of a tangent line and how we found it. The tangent line is also called linearization, L of x. That's just another way of calling it. But you don't have to memorize any of them. See, y minus y1 equals m times x minus x of 1. I hope everybody remembers that. It's a simple point slope formula. Now, if I call this a and f of a, then I can replace them accordingly, and this becomes L of x. Do I have to memorize it? No, just stick with the point slope formula, and that's good enough. So this was the synopsis of the section, and we are going to look at a very simple example. In this case, we are given y equals x times 4 minus x quantity cubed. We want to find a dy, and then we want to find dy and delta y when x is 5 and dx is 0.2. First and foremost, anytime you hear dy, just ignore it and find f prime of x. So f prime of x, or dy dx. Okay, you're going to use the product rule. F prime g plus g prime f. So this is 1 times 4 minus x quantity cube plus, now this one, g prime f. 3 sits in front, 4 minus x to the power of 2 times negative 1. the derivative of the inside, and times x. This is f prime g plus g prime f. And you can take out the common factor of 4 minus x, and you notice this has exponent 3, this has exponent 2. You take the exponent 2, and from this comes out 4 minus x. From this comes out 3 and negative 1 on x minus 3x. Okay, so this gives you 4 minus x. This gives you positive 3 times negative 1 times x, or minus 3x. And so if you put them together, these two is minus 4x. I can take out the 4 from here. Or in fact, I can even take minus 4. So this is dy dx, or f prime of x. What is dy? Exactly the same thing times dx. The same thing times dx. That's all there is to it. Evaluation. Plug in. So now it becomes the elementary algebra, basic math. Plug in, which means replace the x with 5, delta x with 0.2. Needless to say, this is 1. Square root is 1. This is 4. Negative 4 times 4, negative 16 times 0.2 is negative 3.2. What is delta y? Let's go back up here. Delta y is f of x plus delta x, f of 5.2 minus f of 5. And I'm going to leave it for you to do that. Basically, you go to this function, plug in 5.2, gives you minus 8.64. Plug in 5, gives you 5. That's easy to see, 4 minus 5. Okay, becomes negative 1 cubed is negative 1 times 5 is negative 5. With this minus is plus, so we get negative 3.64. The point is, when you look at these two values are very close. One might say they're not that close. Well, it's a matter of perspective. But the smaller the delta x compared to the choice of x, the better the approximation. If you make it 0.1, they are closer. If you make it 0.01, it's even better, almost identical. We want to find y equals L of sine theta. We want to differentiate first. So what do? Flip this over, 1 over sine theta, then times its derivative cosine theta, and it becomes cosine theta over sine theta, or simply cotangent theta. Very straightforward, everybody. Y is e to the power of x over 1 plus x. We have done this before. This is f over g. So we do f prime g minus g prime f over g squared, which means e to the power of x itself, times the bottom, which is 1 plus x, minus 1 times the top, which is e to the power of x. And then you just write the bottom, squared. A simplification of a top requires multiplication here, e to the power of x, to the power of x times x, minus e to the power of x. These two cancel each other. And we put the x in front, x e to the power of x over 1 plus x quantity squared. This was to remind you about differentiation we have done already. But the question is actually find the differential of each function. Which simply put, you tag along dx. In this case, you tag along d theta, d theta. In this case, you tag along dx. Okay. Use differentials to approximate 51 squared. First of all, I hope everybody remembers from algebra, if we wanted to do that, a plus b squared is a squared plus b plus 2ab plus b squared. So you can do it in your head. 50 plus 1 squared is 50 squared plus 2 times 50 times 1 plus 1 squared times 2601. So this could be done pretty fast. Okay, we don't need a calculator for that. I'm just reminding you of that. But in any event, what should we do? First, we want to find a function. What function would that be? Look at the operation that is taking place. 51 squared, we are squaring something. So in this case, let f of x be x squared. Let f of x be x squared. So that means this one, okay? X squared. The second one is choose a number x close to 51 for which squaring is easy to compute. What is the closest number you can think of to 51? You can square it without a calculator. Anybody? That would be 50, because 50 squared is 2,500. Everybody knows that. And so what is delta x? We want to go from x, which is 50, to 51. Delta x or dx is the difference of the two, and it's positive 1. Before we move on, I want to make sure we are clear on that. Therefore, if I said, for example, what is 48 squared, because we are using this, then dx or delta x is 48 minus 50, which is negative 2. So I want everybody to be clear on that. So we want f of x plus delta x, which is going to be approximated with f of x plus dy. And so we have f of x. We need to find dy. To do that, we are going to differentiate this. We get 2x, and dy is 2x dx. We are going to replace f of x with x squared, dy with 2x dx. Okay. Now plug in the numbers. You want f of 51 or 51 squared, or f of 50 plus 1. Replace the x with 50, dx with 1. As you can see, this is 2,500. This is 100. The answer is 2,600, which is extremely close to the actual value of 2,601. And the reason they are extremely close, because this number is very small compared to the choice of x. So we did the differentials. We can do the second method known as linearization. And what it means is that for this function, find the equation of a tangent. And you don't have to memorize any of this. Find the equation of a tangent line. So you need two things. You need a pair, x comma y, and you need the slope. Can anybody tell me what pair do we need? What pair are we talking about? We want to find the equation of a tangent line for this function. X is 50. Plug it in. Y is 2,500. So you plug in 50 into the original function. That gives you the pair. You plug it into f prime. That gives you the slope. So 50 into here goes 2,500. 50 into this gives you 50 times 2 or 100. So y minus y1, y minus 2,500 equals m, which is 100, x minus x of 1, or x minus 50. And we have this one. We are going to add 2500 to the right. We get L of x. This is the equation of a tangent line for this function at x equals 50. So how do you use that to find 51 squared? Find L of 51. And it must give you exactly the same answer that you found here. Otherwise, there is something wrong. Okay, everybody? Cube root of 63.5. We want to use differentials to approximate that. So the very first thing is the function. So what function are we using? Just whatever this is, cube root. This is the action that's taking place. This is the function that you're going to use. So you're going to say f of x is cube root of x. F of x is cube root of x. Next, we want to find an x to be a number close to 63.5 for which the cube root is easy to compute. We don't need a calculator. Any number comes to mind? Cube root of, the closest number to that would be 64. Excellent, because cube root of 64, we know it to be 4. So let x be 64. Now, from 64, we're going to do the math on 64, and from 64, we want to go to this number, and we're going to go down by 0.5. So 63.5 minus 64 results in dx or delta x of minus 0.5. If I want to calculate let's say cube root of 65, I hope you realize dx is positive 1, okay? Because 65 minus 64 is positive 1. And that makes the difference. You'll see it in a moment. Therefore, we need to find f of x plus dy. To do that, we are going to differentiate this. So just as before, we want f of x plus dy, we're going to differentiate this, which is simply 1/3 x to the power of negative 2/3, right? 1/3 x to the power of negative 2/3, right? And if you were to rewrite that, this 2/3 goes down, becomes x to the power of positive 2/3, x to the power of positive 2/3, and this is another way of representing that. And if this is f prime, dy is the same thing, times dx. You can say 1 divided by 3 cube root of x quantity squared times dx, or you put the dx at top. It makes no difference. Therefore, when we want f of x plus dy is the same as f of x cube root of x plus dy, which is dx over 3 cube root of x quantity squared. So what are we looking for? We want f of 63.5. So this is the function. This is the dy we found here, okay? And so with that being the case, what is the cube root of 63.5? It's f of 63.5 or f of 64 plus the dx. dx happen to be negative, and I can't emphasize the importance of it being negative 0.5. It is extremely important, everybody. So plug in. So in this, we replace the x with 64. In this, we do the same thing, and dx is minus 0.5. Now, of course, cube root of 64. We know it to be 4. So this is 4. Let me just do this. So this is obviously 4. This is 4. When you square it becomes 16 times 3 is just 48. This whole thing. 4 squared is 16. 16 times 3 is 48. And negative 0.5 divided by 48. Let me just write it at top here, class. Let's see. So negative, I have room here. Negative 0.5, negative 1/2 divided by 48. You can multiply the 48 by 2. You get negative 1/96. I'm assuming you have no problem with complex fractions and so forth. So 4 minus 1/96 is 3 and 95, 96. If you use a calculator, you end up with this number. And notice how close this number actually is to 4. And so this is with many, many decimals. Again, as far as the question is concerned, however many decimals that they ask you. The second method is the linearization. I want to remind you, and by the way, the calculator answer, let me just clean up this mess. We can clean up everything. This one, take a look. Over here starts changing. That's why I use different. So a calculator value and the value that you have here. It's extremely close. I can't emphasize this enough. Let's look at the same question, but linearization. Linearization requires an equation of a line. To find an equation of a line, I need a pair. I put the 64 here, and I get 4. So 64 comma 4. And the slope, I put the 64 here into f prime of x. And I get 1/4. You can put it here. It might be easier to see it here. If I put the 64 here, I get 4. Squared, I get 16. 16 times 3 is 48. So 1/48. So here's the pair, here's the slope. And now y minus 4 equals m 1/48 times x minus 64. If you do the math, you end up with this equation. I'm going to leave it for you to do that. And of course, if you replace the x with 63.5, it must give you precisely this one. And I highly recommend you keep it as a fraction because it's exact. Okay, so that's the second method of doing that. For y equals f of x equals sine x, find dy. Let's find dy first. And so dy dx is cosine x. Differentiate it first. Anytime they ask you for dy class, ignore it and find f prime of x or dy dx. Now, what is dy? The same thing times dx. Big deal. So that's very straightforward. The moment they say find linearization at pi/6, that means for this function, choose x to be pi/6, find the tangent, right? That's the meaning of it. So what do I need? I need a pair, and I need a slope. The pair, I put pi/6, and sine of pi/6, I know it to be 1/2. The slope, I put it into f prime. Cosine of pi/6 is square root of 3/2. So this is my slope, and this is my pair. Very straightforward. I'm going to use the point slope formula, and I'm going to say y minus 1/2 equals m squared of 3/2 times x minus x of 1/pi/6. So this is square root of 3/2 times x. times minus pi over 6, move the negative 1/2, make it plus 1/2. And if I distribute this, I get square root of 3 over 2 times x. If I distribute this, I get minus square root of 3 pi over 12 plus 1 over 2. And if I keep it as that, this is exact, class. I'm not changing anything. So I'm just keeping it as an exact answer. Okay. Now, they want us to approximate 31 degrees. That means what is sine of 31 degrees? And I'm going to use two ways to show you. I'm going to use the differential and I'm going to use the linearization because we have both of them now. We've done all of them, so we are ready for that. It is important to know we have to use radians. So sine of 31 degrees, 30 degrees is pi over 6 and 1 degree is pi over 180. You have to go that route. And we know f of x plus delta x is f of x plus dy. So what is f of x? Sine x. What is dy? Cosine x dx. So replace the x with pi over 6, dx with pi over 180. This is again this is x plus dx. So plug in. And now, of course, I leave it for you to finish it, but sine of pi over 6, we know it to be 1/2 and cosine to be square root of 3 over 2. At this point, you have to put it into a calculator for an approximation. And the reason I want you to do that, here's what you get, 0.5151. Notice, you know that sine of 30 degrees is 1/2. Sine of 31 degrees should be very close, and it's very close, 0.5151 or 0.52. Extremely close. If you do it the second way using this formula, which is the linearization, we've already done the job. And so if you call this L of x instead of y, everybody, you call this L of x. Okay. And you have to replace the x with 31 pi over 180. So square root of 3 over 2 times x, 31 pi over 180, minus square root of 3 pi over 12 plus 1/2. Now you put it into a calculator and do the math. And with 4 decimals gives you exactly the same answer that you got here. It is supposed to give you the same answer. So linearization can be used. Can somebody read this question, please? Okay, anyone?
One side of a right triangle is known to be 20 centimeters long, and the opposite angle is measured at 30 degrees. With a possible error of plus or negative 1 degree, use differentials to estimate the error in computing the length of the hypotenuse. What is the percentage error?
Perfect. Thanks. So here's what we have, everybody. We have some angle. We have a right triangle. The one opposite that is 20. This is supposed to be 30 degrees, but we have a possible error, maybe plus 1, maybe negative 1 degree. We want to estimate the error in the hypotenuse. So never mind part B, we want to discuss part A. So let's write the given. Of course, one leg is 20 centimeters, which is opposite this angle of 30 degrees with d theta. If this theta is supposed to be 30 degrees, d theta is plus minus 1 degree. Okay. So one leg is 20 centimeters, which is opposite the angle theta, which is supposed to be 30 degrees, with a possibility of a error d theta is plus minus 1 degree, which you have to change it to a radians. And dx is a question mark. You want the possible error in the length of x, the hypotenuse, which we call it x. And so all you have to do, come up with an equation that relates the two. Okay. And so we are going to write one of the trigonometric functions, because this side is 20, you know, sine of theta is the opposite over the hypotenuse. And therefore, sine of theta is 20 over x, which means I can use it this way. I can use a, cross product. I'm interested in finding x. So x is I hope you see that 20 equals x sine theta, or x is 20 divided by sine theta, right? Or 20 cosecant theta. And so you want dx, d theta. Dx, d theta. It's 20 cosecant theta, right? So 20 cosecant theta, the derivative is minus cosecant theta cotangent theta. So dx d theta is 20. Cosecant theta is minus cosecant theta cotangent theta. And what is dx? The same thing times d theta. Plug in. So minus 20. Cosecant theta. You know cosecant is 1 over sine. Sine of 30 degrees is 1/2. So that is 2 actually. And cotangent of theta, cotangent of 30 is square root of 3. And then this d theta is plus minus 1 or plus degree or plus minus pi over 180 radians. I want to make sure that everybody is comfortable with this concept. Remember, this means sine 30 is 1/2, right? Therefore, cosecant 30 must be 2 over 1 or 2, okay? So you use a calculator, or for now, if you keep it as exact, okay, minus 20 times 2 times square root of 2 divided by 180, you get plus minus 2 square root of 3 pi over 9, and that's fine. This is the perfect answer. You should keep it as exact. Or if they ask you for so many decimals, let's say a couple of decimals, plus minus 1.21, and that would be the units of x, which is in centimeters. As far as the percent error, also known as the relative error, by definition, is the amount of error, which is this much, divided by the original one. So dx over x, by definition, is the percent error or relative error. So plug in. And to do this calculation, it's better to go with exact. If you go with this or that part, and you do that, for example, right here, you can see that 20 times 2 cancels out 20 times 2. So you have minus square root of 3 times pi over 180, right? X is 2 times 20, by the way. The reason we know X is 2 times 20 because of this one class. Take a look. We know X, okay, is 20 divided by sine theta, or X is 20 times cosecant theta. This one gives you 2 times 20. This is how we know X is 20. So from here, it's better that we use, so this one, because remember cosecant is, gives you this way. In any event, this is the exact answer. And if you use a calculator, you get plus minus 0.03 or plus minus 3% only. It's a extremely small value, everybody. Hyperbolic functions. I want to remind you of a couple of things. You remember the unit circle, x squared plus y squared equals 1, cosine squared plus sine squared is 1. In the case of a hyperbola, x squared minus y squared equals 1 is a graph known as a hyperbola, and cos squared minus sinh squared equals 1 is the identity that is used equivalent in essence with cosine squared plus sine squared equals 1. Also, you probably remember cos x is e to the power of x or hyperbolic cosine. E to the power of x plus e to the power minus x divided by 2. Sinh x is e to the power of x minus e to the power minus x divided by 2. Okay, so those are some definitions from pre-calculus. Now, with that, we have some identities that we're going to look at a couple of them. Okay, for example, cos squared minus sinh squared equals 1. Hyperbolic cotangent squared minus 1 is hyperbolic cosecant squared, and so on and so forth. Hyperbolic tangent is sinh over cos. Just remember, tangent is sine over cosine. Hyperbolic cotangent is cos over sinh, and so on. If you recall, for example, all trigonometric functions are odd except cosine. Over here, it works the same. Sinh of minus x is minus sinh x, but cos of minus x is cos of x, and it's an even function. Or sinh of x plus y, sinh x cos y plus cos x sinh y. Again, you remember sine of x plus y, or sine of alpha plus beta, sine alpha cosine beta plus cosine alpha sine beta. So if you go back to your trigonometric identities, we do have identities here similar, not exact, of course. The derivative of sine was cosine, the derivative of sinh is cos, the derivative of cosine was negative sine, but here is positive sinh, and so on. Then if cos and sinh are exponential functions, their inverse must be logarithmic functions, and it can be shown that way. And the derivative of sine inverse, if you recall, was like, for example, 1 over 1 minus x squared. Cosine inverse was the same thing with the negative sign. If you look at the sinh inverse, they are similar, 1 over square root of x squared plus 1, and so forth. And they can be proved. You need to get comfortable with them with a little bit of a practice. So I want to look at a couple of proofs quickly. For example, I want to prove a cos squared minus sinh squared equals 1. And I'm going to remind you of what we have seen previously in college algebra in pre-calculus. Definition of a cos, definition of a sinh is used to prove that. And then furthermore, for other proofs, we use the proofs that has been an identity already, and we prove them. So for this one, instead of cos, I'm going to use this one to the second power minus instead of c. So I'm going to start, remember we start with the more complicated side. In this case, I'm going to start with the left-hand side. We're going to square this minus square this, right? Now, let's do that. If I want to square, first of all, both of them have the denominator 4. Let's look at this one. When you raise to the second power, this becomes e to the power of 2x plus 2 times the first times the second, plus this one to the second power is e to the power of minus 2x. So, by the way, this one just takes a negative sign. So it should be very obvious. It's really not a big deal, okay? Very straightforward. I hope it is simply understood, okay? Now, what happens here? We are going to look at these two and realize this times this is e to the power of 0, and therefore this is 2, and this is also 2 with a negative sign minus 2. So I want to make sure we understood what happened here. Class, e to the power of x times e to the power of minus x is e to the power of 0, which is 1. We should know that. Okay. Now, if you subtract the second from the first one, in other words, this is 4. This is e to the power of 2x plus 2 plus e to the power minus 2x minus, we are applying this negative sign, e to the power of 2x plus 2 minus e to the power minus 2x. So what happens is this one cancels out this one. This one cancels out this one. The numerator is 4. 4 over 4 is 1. We just proved Cauchy squared minus Cinch squared equals 1. Now prove 1 minus hyperbolic tan squared x equals hyperbolic secant squared x. In trigonometric function, we had 1 plus tan squared equals secant squared. Okay, slightly different, but so what do? We start with what we just proved. We are going to start with Cauchy squared minus Cinch squared equals 1. We wanted to make it look like this. In order to make this 1, let's divide everything by Cauchy squared. Divide everything by the first term, Cauchy squared. This is 1. Remember, Cinch over Cauchy is hyperbolic tangent, so this is hyperbolic tangent squared. Reciprocal identities. 1 over Cauchy is hyperbolic secant. So 1 minus hyperbolic tangent squared equals hyperbolic secant squared. So we proved that. It's very straightforward, everybody. We want to take the derivative of Cinch of 10x squared. So first and foremost, the derivative of Cinch is Cauchy. So Cinch results in Cauchy of the same thing. So again, you want to differentiate that. Here's what I highly recommend you do. Cinch and pause. The derivative is Cauchy. But you have to have the argument, whatever the argument may be, you have to write it. So you have to write the 10x squared. Now the chain rule. What is the derivative of 10x squared? 20x. And you just rewrite it. So just like before, remember when we did the trigonometric functions and I said you come across sine or cosine, say sine, pause it so you recognize which one is the main function, the outer function, the shell function. So you put the 20x in front, so you have 20x cos 10x squared. What about cos of square root of x? First of all, this gives you Cinch because the derivative of Cinch is cos, the derivative of cos is Cinch. Both of them are positive, so Cinch. But Cinch of what? Whatever the argument, square root of x. And then times the derivative of square root of x. By now, you should know the derivative of square root of x is 1 over 2 square root of x, or square root of x is x to the power of 1/2. Its derivative is 1/2 x to the power of negative 1/2, which is that one. Okay, and you can rewrite it in this fashion. Okay. We want to differentiate where f of x is hyperbolic tangent of 1 plus e to the power of 2x. And hyperbolic tangent is hyperbolic secant squared. Okay. Remember the derivative of tangent was secant squared. The derivative of hyperbolic tangent is hyperbolic secant squared. So secant, hyperbolic secant squared of, so that's, again, let me do this. This is the shell function. So it gives you that with the same argument, 1 plus e to the power of 2x. Now we want to differentiate this. By the chain rule. How do we differentiate? 1 is 0, so never mind. How do we differentiate any exponential itself? Is the exponent x? No. By the chain rule times its derivative, which is 2. And you put that in front. 2 e to the power of 2x, hyperbolic secant squared of 1 plus e to the power of 2x is the final answer. Y equals cinch inverse x squared. And I have the formulas for you here. So the derivative of cinch inverse x is 1 over square root of x squared plus 1. So if I want to differentiate that, clearly when you look at this one, if I change the x to u, the numerator takes the u dx by the chain rule. If I change it to g of x, then we need g prime in the numerator. So first, I'm going to just write this without the x squared, even if I don't give you that. So instead of x squared, I'm going to write this one. So I'm going to square this piece, becomes x to the power of 4, and I put it here. And then by the chain rule, I need the derivative of that. You can say du dx, I need g prime of x, which is 2x, and I rewrite that as the final answer. Cinch inverse of tan x. Again, remember cinch inverse is your shell function. So you can write it in the same fashion without writing what's in there or use that or use that. So don't write anything here. So what goes in there? This argument squared, and by the chain rule, either du dx or g prime of x. The derivative of tan x goes here, secant squared x. All right, now it gets interesting. So you have secant squared x over the square root of tan squared plus 1. You know tan squared plus 1 itself is secant squared. But when it's in the square root, please remember, this comes out as absolute value of secant x. Doesn't come out as secant x unless you know it's positive. And when you divide the top by the bottom, it continues being an absolute value of secant. If I want to multiply these two pieces, I use the product rule. F times G gives me F prime G plus G prime F. So e to the power of x is itself. times cosh x plus, now the derivative of cosh is sinh plus sinh x times e to the power of x. And I'm going to write at top of it as f prime g plus g prime f. We can factor out the e to the power of x. Now you may notice if you add these two, e to the power minus x and e to the power minus x cancel each other with the negative sign. Then you have 2 e to the power of x over 2 or simply e to the power of x. So I hope you recognize this, meaning this becomes e to the power of x itself. E to the power of x times e to the power of x is e to the power of x plus x or e to the power of 2x, which makes it the final answer.